Hey there. So I've been working on a new audio editor for my for JPrez. Of course, JPrez is a presentation tool for programmers written in J. But this piece is actually written in Godot. So Godot is a tool for making video games, but it's also something that has a really nice animation engine. And so I've been using it for, like title animations and some just decorative things that go on top of like the REPL and the editor and that kind of stuff in my videos. In particular, I'm working on one for my Mandelbrot set video, where I've got one line of J and I've got some, I've got a nice little setup where I've got, that one line of J becomes like a navigation for the video, where different parts of it get highlighted, and so that's an animation I created in Godot where I can press some buttons and toggle the display of certain highlights and certain signposts that say this part does this and this part does this. And likewise, I've made animations in the past for as I said, title screens, but also I've got a start on a little visualization of the J interpreter, and basically I just I've come to the realization that I really like Godot for animation, and so I intend to use it, to continue using it and continue investing and learning it. I'm definitely not a Godot expert, but so in addition, I to all that, I've got this need for a what I want to be able to do, I script. This is a completely unscripted video, if it's not obvious. My live streams are unscripted, but I have a the desire to make scripted videos where I actually plan out exactly what I'm going to say, and I write it like an essay, and plan out exactly how I'm going to present things. And so the video, the Mandelbrot set video I'm working on with that I was just talking about, it has I recorded it, and I noticed that the problem that that as I went back and edited the audio and took out all the stammering and the long pauses, that it affected my video. Because I was recording the audio while I was moving the mouse around and drawing the presenting the REPL. Even though the REPL is recorded, I still have some trouble syncing that up. And then when I got it, what I felt was right, working live, and so I've got JPrez. I'm pressing buttons to replay my typing, and it looks the way I want. And then and then I'm speaking over it, and the voiceover needed to be edited. And then when I edited the voiceover, it turns out, well, I'm screwing up the video, the video of all the things. And so I spent all this time making these recordings so that the text cursor looks good and natural in the way I want it to look. And then all of a sudden that gets edited out, and then it's wasted effort, and I don't want that. I wanted to show the typing a certain way, and so what that has led me to do now is what I want is a tool. Oh, and I've wanted this for a long time. A tool that would give me the text on the screen and allow me to record each sentence one at a time. And so I built something like this. It's not ready to go yet, so this is a work in progress. Basically, I had kind of a brainstorming session about this a week ago on my live stream, and yesterday I finally had some time to jump into Godot and make something. So I'm going to show that. So let's go ahead and jump over there. Let me just show the application. It's very rough, but let me go ahead and share my screen. Oh, not that one. Here we go. Okay, so this program is currently called. I couldn't think of a good name, so I called it Fnarbnelix. using a bunch of invalid consonant clusters. And I'm going to actually put my headphones on for this just so I can hear what you're hearing. So that's obviously not the name of the program. I just ran, I just put together a stupid name whatever, that was not a valid English word. Okay, so but the idea is that and again, this is very, very rough. Like lots of things are not working. But in fact, let me actually just restart. I don't know why I have that there. That should be completely empty. Yeah. Okay. So the way it works, it says, I don't know if you can read that, but it says hold Shift to record and press space to play a sample. And then these are your prompts, right? So the idea is that you would put your script in here, and eventually this will scroll, and that it would be more readable and whatnot. But so like this says, this label says 0, 1, 2, 3, 4, 5, and so on, all the way to 9. And then I guess if you want more than 9, you can actually resize your screen and it'll do that. But eventually there'll be like scrolling and something closer to like a text editor here. That's weird. I'm not sure why I get the border on the right over here. I see a black line in OBS. All right, well, whatever. Anyway, so the idea is you pick one of these slots. You can't use the mouse yet, so you use your keyboard to pick one of the slots, and then you would record the text. So if this is the Gettysburg Address, you might say, 407 years ago, our fathers brought forth upon this continent a new nation. And so then that records it. I was holding down Shift, I recorded it, and now if I hit the space button, it'll play this audio back. 407 years ago, our fathers brought forth upon this continent a new nation. Hooray. So we've got the waveform displaying. We've got the cursor, and then you can also kind of do things incrementally. So A, B, C, D, and then you can go again, E, F, G, H, I, J, K, and you can record it in chunks like that. A, B, C, D, E, F, G, H, I, J, K. There seems to be like a lag. I had this problem with OBS too. It's like there's like a slight delay of like a tenth of a second maybe, where you can see where physical. In my experience, my subjective experience is that I'm pressing this down and immediately starting. So I press Shift and I immediately start talking, but I always get this delay like at each one of these starts, and then at the end, there's also a clipping sound. So if you wait for the cursor to get right about here, A, B, C, D. That I was saying D, but I think you can hear the clipping a little more on this one. I think E, F, G, H, I. E, F, G, the G cut off. It was more like E, like G, J, K. And that seems to be something to do with the delay. So I need to adjust that. Basically, when I take when you let go of the button, there should probably be a little lag before it actually stops recording, just because of that delay. Anyway, but then the idea is now you can move this up and down, and now you can play your text. What I'm missing, the thing I need to do right now is be able to click and set this this cursor, right? And then the idea is that wherever the cursor is, you'll be able to click to set the cursor, drag to select something, and then you'll be able to delete. So you should be able to drag here and delete that text, and then put the cursor like over this. So this got clipped, so I would be able to record this, hit Shift or sorry, highlight this little area, hit Shift or hold Shift, say the EFG or whatever I was saying again, and then and then edit that in place. And so then the idea being that you can kind of like use basic cutting to get the text basically the way you want it, or you need to get the audio basically the way you want it. And then at the end, you'll be able to hit a button and it'll generate the transcript for you. It'll compile all this into a single WAV file. You can save this right now. So if I press the saving is kind of proof of concept right now. But so if you press a button, I think you press S and it saves it to a WAV file on my disk. I've got the names are hard coded right now, so I don't want to save it. I have some files I wanted to keep for testing purposes. And then I can't load yet, but I have located some code that allows me to load. And then the next main thing is I want to hook this up to JPrez. And so obviously we've got two different runtimes. JPrez is a console application. This is a GUI application or a direct video application in Godot. And I'm planning to communicate between the two over like WebSockets and set up a little messaging protocol. So the idea being that as you go to you'll be able to run this application and then work in JPrez, and then you'll be able to do all the recording using JPrez keyboard shortcuts, or conversely drive the presentation from here and just get the recording done. Don't know exactly how it's going to work yet, like as far as like user experience goes, but that's the basic idea. So these two will be synced over WebSockets, and they'll be able to control each other, or one will be able to control the other. I'm not sure exactly which. Anyway, so I wanted to just go through the code and just for posterity and for anybody who wants to learn Godot. I really like working with Godot. It's a nice application for it's meant for building games, but and I have made some like toy games with it. I've started porting some of my Flash games to Godot in the past, but basically I really like it for just the it's a single executable. It's small. It's got a nice simple model for how you structure graphical user interfaces. It's got the ability to like layout controls and keep them all the same width and height, and arrange them in columns and that kind of stuff. Or you can arrange things however you want. Like I've got like a scroll bar. So when this gets too long, there should be a scroll bar appearing here. That's not working yet. But the idea is that you'll be able to use a scroll bar and have all that logic done for you, and you just I'll be able to use that to say what part of this do I want to draw, and it's just a really nice tool. It's a nice tool for rapid application development. Like I said, I started this. I think I spent like 1 hour last week. I had one night free, and I spent an hour just like learning how to get audio working at all. But the entire UI, including rendering this waveform and drawing all that took me 1 day. So, and again, I'm not an expert in Godot. So, anyway, so let's dive into the code and see exactly how this works. I'm going to turn off my camera here because Godot is a little bit cramped, and well, I just don't need this right now. So, all right. So, first, I'm going to show. This is how you actually, let me do this to studio mode so I can go back and forth. If I say green screen. Oh, that's interesting. There we go. Okay, so I guess I have to wait for my camera to turn on whenever I take it out of the scene. That shouldn't actually be the case. I'll worry about that another time. All right, so when you're in, I'll just start up Godot. So you run Godot. You can't see it, but I'm running Godot 3.3 here. The latest version is 3.4. It came out just like a couple days ago. And it turns out there's actually a bug in this. So I downloaded this audio mic record demo, but I'm actually going to recreate this here just from scratch, just to show you. But this is from the asset library. So I think if you say audio, well, yeah. So this is what I had 3.3 installed, and then nothing shows up under here because they moved everything to 3.4, and so now everything is tagged with 3.4 and all the. I don't know if that's a bug or what, but if you go into well, whatever, you basically, let me see. Godot 3.4. our 3.3 asset lib. Let's put this down here. Godot asset library, and then under here, yeah, you can search for audio, and all kinds of cool stuff came in here. Ooh, audio loader, that's interesting. Generator, so audio mic recorder demo, and it sees marked as 3.4, so that's unfortunate because it doesn't work in 3.4. It only works in 3.3. It only works up to 3.3. I filed a bug, and like other people have jumped in, and they had the same problem. So hopefully this will be fixed in 3.4 something or whatever, or 3.5 or whatever. Anyway, they're all pretty compatible. So I'm just going to go ahead and just before I jump back into this, I'm going to go ahead and let's just go back to, I have another project open. So oh yeah, this is complete tangent, but just I'll just show you the thing I was working on. Yeah, I don't even think this does anything. Oh, maybe it does. Yeah, so this is meant to be a visualization of the oh, I see, of the J parser, and I need to I need to learn how to use it again. It's not scripted. My keyboard, my arrow keys are causing that to work. Anyway, it doesn't matter. So this is something I started a while ago, and I probably will revisit this at some point. Just another example of an animation I want to show. I know that didn't make any sense, but basically you got tokens and they're moving around, and you're saying what part of speech they are and whatever. It's going to be eventually a demonstration of how you parse this thing. It's keyboard driven, and I don't remember what the keys are right now. But that's the story for another day. The point I was doing here is just a project. You go quit the project list, yes, and then you have this project manager again. Do I not have this open already in a window? Whatever. 1 second. Okay, so right. So in the new one, I'm going to say new project. It's a little annoying. So I'm going to say when you do the C temp, you say C. This is, I think, I do not like this. So we'll call it some other thing. Create folder, create an edit. That's how you get Finarblinks. No, that's not actually what I did. I actually purposely constructed a name that had invalid consonant clusters. Anyway, so the way you do this, this is start of how to do. Put a little marker here, notepad. This is my title screen, right? How to do setting up a Godot project for audio. That's my title screen, right? I should really, we'll see. So eventually I'll have a tool that will allow me to do things like this on the fly. Okay, so I guess PowerPoint is such a tool, right? But anyway, so you say project settings. The first thing you need is audio. This is specifically if you want to use the mic. You have to check this. So you go general, you go to project. So again, project settings, project settings, go to audio and click on enable audio input. And then generally your mix rate, you want that to be, you probably just want these all to be the same. But this is the key. So this enables your microphone. Okay. So then you have to restart. Okay, so save and restart. and it goes full screen, and boom, boom. And then the next thing you do, you have to go down to audio. This is your master output, and so you need to create a new bus. And this you were going to call record. You can call it whatever you want, but traditionally or in the demo it's called record. And then you add an effect, and the effect is is it capture? It's record. Okay, and then we're going to mute it in a second, but I'll show you what happens when you don't mute it. All right, so then you create a scene, 2D, 3D, doesn't matter, and then you have to add two things to it. So now you've got this like existing in, like Godot is now capable of using audio, but it doesn't do anything with it yet. And so now you have to add audio stream player. And you can add the 2D. These do like spatial audio, but this is audio stream player, which is just non-spatial. It doesn't do any kind of processing for that. And you're going to add two of these. So one is for input. So audio stream in, or we can call it, in or mic or whatever, and then one for out, and then audio stream player or out or whatever. And the idea is that you set this to autoplay, and then as soon as you put a stream on here, it's going to stream that audio, and then stream in. Oh, and then also this one you want to hook up to the master audio, so you hook it up to the bus master audio stream in. You hook this one up to record, and then so this is like the output. So the output of this is going to the record one. And then the output of this is going to master, but it is also recording it, right? Because I've added this effect here. I guess you could probably just record everything, but you probably don't want to do that. If you wanted to record everything that ever played, you would do this. And so then the stream, it's a little clunky, right? So the stream, not clunky, but it's not clear that you're building a graph here, I think. So then you want an audio stream microphone. And so now that means that now this is in your scene, that when you play this, the microphone is going to come in. It's going to pick up on the microphone. It's going to send it to the record, and then that's going to, that's going to patch through to master, so it's going to come out. So if I play this now, you're going to start hearing an echo. So if I play this, now you select your main scene. You have to save your scene, so we call it main. Let's save it. We'll call it main. And now when we run it, now you select the main scene, open, and now you should hear. Now you don't hear it. Okay. Testing 1 2 3. Is my desktop audio not? Hang on. It says monitor and output. I should be hearing this. Testing. Hello, 1 2 3. No. Okay. So let's see what I did wrong. As I said, it's a little bit tricky. Maybe you just do this. Oh, there we go. Yeah. Testing 1 2 1 2 3. Yeah. That's annoying. So you hit mute, and then now that problem goes away. So it's recording, and then it has a record filter, and then what you do is I'm gonna go to my real project now and show the thing. But yeah, now in the so now you in your code you create a script, and you can close this. Let's move this up a little bit so I can see the button. So you can close the audio tab. Now that's all you ever have to do for that. So now this is working. And what you do is you say audio stream in, audio stream. Sorry. Funk ready. So inside that, you say audio stream in. Sample. Sorry, stream. Sample. No, sorry. Well, stream. And then you can click on that and get some data. But that happens to be a var mic is, to give some type information, is a audio stream microphone. Oops. All right, let's just start over there. Let's start over. We're going to say def, we're going to say funk ready, and then we say audio stream in. Well, I don't even remember. Let's look at the other one. Let's look at my code here. I'm so prepared. I thought I had this in my head, but so this has grown quite a bit. So let's jump to the main, and let's zoom this out a little bit. So when I hit record, we say mic. So mic is audio server. Oh, okay, that's right. Yeah. So here. So let's zoom this out. So first, you in order to get the microphone, which is an audio effect, audio effect record. You have to do this. So we're going to get the index of the record one. So we're going to look through here and find the one called record, and then get the effect 0, which happens to be the record one. So the 0 here corresponds to this first effect, which is record. All right, so that worked, meaning it didn't give me an error. And then when you're ready to record, then that's when you say, so we've assigned this to a variable called mic, audio effect record. And then now we just say set recording active is true or false. And then once it's true, if it is true, then we can we can grab that recording with get recording, and that gives us a get recording, and it gives us an audio stream sample. And from there, you can get the raw data, and you can, there's some. For me, this winds up being the format is 16-bit and stereo. So it tells you stereo, and then the mix rate, and then this is what was set in the project settings. So project settings, audio, and then the mix rate. So the mix rate tells you how many samples you get per second. So the way this works, it's called pulse code modulation. So it's like AM, so amplitude modulation, pulse code modulation. And yeah, so this is a good picture of it. So basically, you're looking at the sounds waveform, and you're just whatever the diaphragm, whatever the thing is moving back and forth, that picks up the sound or generates the sound in a speaker that causes the waves in the air. You're saying at what position is this in the wave, and you're just taking samples of it, and then you're mapping that to a number between, depending on if it's 8 bits, then you're mapping it between 0 and 256, or between a negative 128 and 127, and same, likewise for 16-bit, you do it to 65536 or whatever half of 655, 2 to the 15th power is. So that's what's going on here, and so the actual data structure is it's always bytes, and so if it's 16, if you're doing 16-bit encoding, you wind up with 2 bytes for the left ear, 2 bytes for the right ear, 2 bytes for the left ear, 2 bytes for the right ear, and you have to take those 2 bytes and turn them into the actual number. Anyway, so that's what we've got. So that's like the basics, and as I said, everything that I just described is what you get when you do the that demo program, this demo program here. So you can get all that for free, and then there's also a button that lets you save it to a WAV file externally. Yeah, so save to outside area. Anyway, but it wasn't clear to me how it works, so I just wanted to go over that. It took me a while to like reverse engineer what was actually happening there, and to understand how that was put together. So you're making like a little graph structure between the objects in your these input objects and these audio buses and the actual samples and whatnot between them. So hopefully that was at least give you some kind of orientation into how that thing works, or how that thing was constructed. Anyway, so now I guess we're in part 2 here. Let's see, view. Make my font bigger here. Okay, so now I guess this is well, I can show you recording the clip, rendering the audio clip. Okay, so that was actually that was actually the trickiest part for me, because I needed to that was the trickiest part for me because I had to actually parse the data and figure out it wasn't clear what the format of the data was. So this file audio clip, draw audio clips, samples are in PCM format, pulse code modulation. Pulse code is the amplitude as 8 or 16-bit number, and data format is an array of alternating left sample, right sample values. So once you've got that, that's not that hard to do. So we're gonna extend color rect. So in your scene, the audio clip is actually this thing. So it's just type color rect. So you just go up here and you say color rectangle, and that gives you not surprisingly, it gives you a colored rectangle, and you can insert that in your scene. And I've decorated it a little bit because this is the red bar that moves across, and then the intent is to implement scrolling, so some kind of scroll behavior. That actually does nothing yet, so you can ignore this. I couldn't explain it yet because I don't know what I'm doing yet, so this is just temporary. And you don't necessarily need this here. This is going to be part of the scene, and then this is going to be turned into a in Godot at any time you can right click on a node in your tree and you can say save branch as scene, and now a scene is like a component. A scene becomes like a user defined component that you can insert anywhere you want. And so the idea is that when you define a script and a scene, then you can use that script to define variables that show up in the inspector here. So now I've defined sample, start, end, and head. And now I have sample, start, end, and head as script variables that you can edit. And so these are I want time scale. Time scale is a little bit defined a little bit lower. And so these, which shouldn't be, but I screwed up. I haven't cleaned up the code yet. And so probably this audio stream player will be a link to an audio stream player, and you'll be able to select it from up here. But for now, I just stuck it inside the thing. But the idea is that that you can build components, and then I try, you want to encapsulate as much as possible. So I try to make it so that I have, so that it looks like I have these two objects here. So I've got an audio stream input, and I probably should have an audio stream output. Like this should be out here. And then like this should be able to say, select that and say, hook this up to audio stream output. And that's easy to do. I just haven't done it yet. And then I've got the label here, which is, just my, my documentation. And then this is the clip scroller at the top. And then the prompter at the bottom, which shows the, it doesn't have anything in it right now, but that's where I define the prompts. So here they say 0, 1, 2, 3, 4, 5, but the idea is that they would show the text of the text that you want to record, and then the path tells you like what directory do you want to record that into, and then it'll generate a WAV file for each one of these things. So the idea is you would have your script like ready to go before you got to this point. You're not editing the script anymore. You're just recording what the lines that are there, and you're going to edit the WAV files and get the best take. Okay. So that's kind of the workflow I'm envisioning. Obviously you can do a lot more in the future, but that's kind of like the minimal viable product that I wanted to make for myself here. And then this tells you the root path. And the idea is that you would have one of these, since this is like one WAV file per sentence, you would probably have a path per scene. So the idea is that that as you move back and forth in JPrez between scenes, the WebSocket communication would somehow set these variables, and you would have set these prompts and whatnot, and then you would just go back and record them. Haven't gotten that far yet, but that's the intent. Okay. That was really more like, that was more like a layout of the program. This is rendering the audio clip. Okay, so rendering the audio clip for real now. We go in here. We go into clip scroller. All right, so the text for this is just like basically relaying stuff. So that was more. This is nothing. Actually, this complains if you don't have a script, because containers have to describe how to arrange their children, and so that the intent is to do that. I'll probably change this later. Audio clip. So this is the real one. This is the important one. So we have a sample associated with it. So something outside the stuff that records it attaches it to attaches the sample once it's recorded. Attaches it to this sample variable on my audio clip. Or actually, sorry. The way it actually works is you set the variable on this, because again it's meant to be outside. So you set this sample, and when you set this, this has what's called a set get. So it allows you to put setters and getters on it. So when you set it on the clip scroller, then the set sample is called, and that sets the start to 0, the head to start, and so on. So you're adding a new recording, and so then we just move the cursor all the way to the left, and then set the head to start, and then if depending on if it's empty, then we or you pass in a null, then you just the end and the start are the same. Otherwise, you go to the end of the thing, and then you get all the data. And then the important thing is that the clip node sample is set to X as well. And clip node is just the audio clip, right? So now we're at the audio clip, and this gets set, and so now we have the data. It has its own set sample, and so we set the variable sample. This is how you do a setter. You set the actual data to the incoming value. Offset is for drawing, so we're gonna you'll see in a minute, but we're drawing one value per pixel, not per sample, because again, there are 44,100 something like that samples per second, and that's if you did every sample, it wouldn't fit on the screen, even in 1080p. You don't have enough space, so you have to shrink it horizontally. So, and then the bytes per sample is just the idea is that now we're going to inspect the format, and these are the different formats. This is 8 bits, 16 bits, and this is some kind of like encoded, compressed audio kind of thing. I plugged it in and I got this. So I guess my microphone or the operating system or whatever, they all conspired to give me this format, and I have not tried to make this work with anything else other than this, except that I did abstract this a little bit so that at least you would get the number 4 out of this, and maybe we could make an assertion that says, okay, I'm expecting the number 4, and if I don't, then I need to update the code. Update is whenever you have a control or a they're called canvas items. So any of the 2D items are canvas items. I think so control extends canvas item, which extends node. Oh, that's interesting. I would expect node 2D to be a canvas item, but I guess node. Huh. I guess node 2D. Oops, sorry. Go away. Not important. I would expect. I would have thought that canvas item was a node 2D, but I guess canvas items are just items on a canvas. Maybe node 2D is a canvas. Anyway, controls are basically meant to be like UI related nodes, and the color rect is one of those things. So we basically in any kind of canvas item inherits or has the ability to call this update function, which causes it to redraw. And then when you do that, you have the ability to call any of these functions to draw interesting things on the screen and compose whatever. And then this draws to a texture, and so it's buffered. And so you don't have to redraw it on every frame. You draw it once, and then whenever you change it, then you can redraw it. So basically, in my case, we draw it once whenever the waveform changes, basically, or whenever the scale changes. I don't have anything bound to cause the scale to change, but in theory, when you set you set the active, so that changes the color. So you can see we'll play it here. So 0, 1, 2, 3, and you can see that the color changes from white to gold based on whether or not whether it's active or not. So that active flag controls its color. And all I did for that was just color is a property of color rect, so you can change that to whatever you want. And then you call update, and then that redraws. I'm not actually sure you even need this, because I think maybe you can change the background color without actually changing the stuff that's drawn on top of it. But in any case, I call update anyway. And then when you set the sample, the audio clip, that also causes an update. And so then this value this bytes per sample is used within the loop, and so I cache it in a variable rather than calling this function every time, just to hopefully be a slight improvement in speed. So then once you call update, that, as it says in the docs here, it triggers the any canvas item can draw. For this, update must be called, and then notification draw will be received on idle time to request redraw. Because of this, canvas items don't need to be redrawn on every frame, improving the performance significantly. Several functions for drawing on the canvas item are provided. However, they can only be used inside the object notification signal or draw virtual functions. So you get this notification to draw, and then you have access to the texture or whatever, and then you draw. And then you can call those functions. But draw is the place where you would normally do that. So if you define a function called draw, then when update is called and you are being asked to redraw, then you have access to all these functions. And so of course I'm mostly using draw line. All right, so audio clip back in here. So when we call this, we go all the way down here to draw. So I just had to print the sample info just so I could see what data I had to work with. And so sample format is, I just gave it a name for all these things. You actually get a numeric number. So we map 0, 1, and right. So the slot, the sample format 0 is 8 bits, so it has 1 byte. 16 bits is 2 bytes, and then I didn't know what to put here, so I just put 0 here. So bytes per sample is using that, and then these are the strings that correspond to these formats. Godot and nums they seem to just act as integers, and you can use them as constants, but I don't know how to print the actual value associated with them. Maybe there's a way to do that, and this is redundant, but I just I just made an array of the 3 possible values, which I got from if you look at mix array here. I don't know how to get at this, but the format, the num format, right? These are the 3, 0, 1, and 2. Okay, so I just made 2 arrays, so map to those values 0, 1, and 2. Okay, so anyway, so when you record, when it first tries to render something, it prints out all the information about this. So probably not important. Probably could comment this out, but it was helpful when debugging. Because it wasn't clear to me like exactly what the format was, but now I know. The format is so basically we're going to start on the left side. So this is the origin. So O is the origin, and it's going to be 0 and halfway through the vertical. So 0 is the x coordinate all the way to the left, and the halfway up and down, halfway vertically. So now my pen is the point that the last point that I've drawn. So really this is just O, but I just make it explicit, I added 0 to it. Meaning this is the origin. Pen is at the origin, and then as we go along, this is the starting point. We're going to draw. You start here, and then you draw each one of these little squigglies, and then at each point you're going to end or start at whatever the sample value is. So the other end of the line is going to be next. All right. So now for x and range of this, so basically for each pixel going left to right, we're going to say, again, we have 44,000 samples per ear per second, and so so we need to subsample that. So we need to just like map it to a point to a sample. So each pixel is going to be mapped to a single sample. We probably could like average them or something like that because you lose a lot of information. But I'm not. Watch this. I found this interesting. So part of my singing here, but do, re, mi, fa, sol, la, ti, do. And you can see that I spent too long. Let me do another one. Let me do that again. I can't erase right now. Do, re, mi, fa, sol, la, ti, do. So you can see that you can get information like the pitch is somehow rendered as density here. And I think these waveforms could be drawn a little better by taking some averages. But like what I mostly care about is where are the pauses, so that I can edit the long pauses out, and just be able to get a visual sense of what the words are, because you can you can do re mi fa sol la ti do. You can once I get the ability to click somewhere and highlight that, I'll be able to like remove a single word at a time, and if I mispronounce a word, I can just re-record that one word. So that's what I'm shooting for. So I think that I worried that the subsampling does not give you the best representation of the actual waveform. Like maybe if you were a real audio engineer, you would cringe at seeing the way I'm rendering it here. But this is good enough for me. Basically, if I can see the spaces and the volume and the spaces, then that's all I care about. And it's nice that the frequency gives you the kind of striping pattern gives you some information about the frequency, I guess, although not much. Anyway, so and the way that's achieved is we're scaling the time. I wonder if I can actually change that in real time. I'm not sure. This is a tangent here, but let's. So now this is running. So let's see if I can adjust that in real time. I think I can, but I'm not sure. So if I go to the clip scroller and I set the time scale, I set this over here. No, I'm not going to be able to do that, but I can go on this side, move this to, and I know this is a tangent. I'll move this to the side, and then I put this over here. And this might not even work after all that. That didn't work. I'm not sure that propagates, so let's try it down here. No, that's not changing in real time. That's too bad. Maybe I'll, for the next video, I'll do some experimenting with that. But the idea was that you'd be able to roll your mouse and zoom in and out on this thing. Because getting the scaling right was vitally important. It took me this little chunk of code took me a long time to get working. It took me most of the day to get this working. Most because I didn't know what to do, and so that's again why I wanted to do this. So the offset is, where do we start within the time offset in seconds? Like, where do we start? So all this is to take the x value, which is, we're mapping x to seconds. So we're going to start with the time scale. So the time scale basically maps pixels to seconds, to a point in time, pixels to time. And then we also have to map that back to the actual data. And so we multiply by the number of bytes per sample. And so then now we can call this, so if we're past the end of the line, so if we have a really long, a really short audio, then we stop, and we stop our drawing. But otherwise, we get the next sample, and then we scale it. So this is going to be a signed number, and so we're going to, which is why we put the 0 in the middle of the screen here. So this is going to be a signed number between 0 and 2 to the 15th, which is this number, 32,768. So we're going to take that sample, divide it by that number, giving us a number between -1 and 1. And then we're going to multiply that by the 1/2 of our height. And that maps us vertically to pixel space. And then we draw the line. So then that becomes our x point. So x, our end point. So x plus v plus v, this is v, x plus v, and or xv plus the origin to move it halfway up the vertically becomes the next endpoint. And so then we draw the line. And so then the trick is just parsing the code. So this is actually all you need to draw the line. This is actually pretty straightforward. you have to deal with the scaling and all that, but it's not that big of a deal. This is the step that was giving me trouble. And I should definitely say thank you to this person. I forget his name, starts with a Z. So we'll credit this guy, or person, sorry. So this person, Zylan. So thank you, Zylan, for providing this information. They are working on actually reading audio samples from and then saving them as. I'm sorry. I'm not actually sure what they're trying to do. It seems like you could. This might have predated the load, because you can load a WAV file now. I'm sorry, no, you can't. You cannot load a WAV file. So maybe that's what they're trying to do. But there's a save to WAV file function for audio streams, but not a load. You can start with a you can import data and make them part of your project, and you can put like WAV files, and I don't know about WAV files, but you can definitely put like OGG files and MP3 files into your Scene Explorer, into your project. So you can drag them in here and then play them. You map them to clips or whatever. But you cannot you cannot load. There isn't a built-in function to load like a WAV file just that you've recorded yourself. So you can save to disk, but you can't load it back easily. That sounds crazy to me, so maybe I'm wrong about that, but I guess the intent was you had to roll your own. It's not built. There just isn't a load function, which is weird. But somewhere, I guess in the next video, I haven't used it yet, so I don't have my bookmark handy. But somewhere in here, there's a bookmark to load that file. Anyway, to reload files, and of course, I'll need to be using that very, very, very soon when I want to edit a project that's already been worked on. But anyway, get stereo sample. Thanks for this. Thank you, Zylan, for sharing your code online. So anyway, so then D is sample data. So sample being a audio stream sample. It has a data property, and data is a pool byte array, which is just an array of bytes, exactly what it sounds like. I'm not sure what the pool optimized for memory usage does not fragment the memory. Okay, that's there's all kinds of pool X arrays, right? Pool string arrays, pool whatever. But anyway, you can append arrays. This is how I do the recording. Append one recording onto another. Definitely, I will be about to be grabbing subarrays when I want to override and delete and that kinds of things, and reconstructing this. But basically, we have a basic. It's just an array. It just acts like an array, and we just have to do. Again, the left and right are intertwined. So given I, then you have 2 bytes for each channel. So the left channel and the right channel. So given the offset of the first byte, the second byte is that plus 2. So I call that J. But I wound up just drawing the left channel only. So at some point, the logic is the same for the 2 channels. You just for a while I was like adding them and dividing by 2. So shift right 1 is divide by 2, and that didn't give me like the results look pretty much the same. So I was basically averaging the left and right channels, and of course you can also draw them separately. But I'm speaking into a microphone and doing audio, so I really I don't even need stereo at all. Maybe I could find a way to turn stereo off, but in theory, you could just draw 2 lines of these and draw the left and right together, or pass in a second parameter, or pass in you know, something else. So here, because of the time scale and the bytes per sample, we're actually jumping not just we're not just jumping every 2 bytes, but we're jumping, or every 4 bytes, we're jumping four times 128. So we're taking subsamples, which I was actually kind of surprised. I thought maybe you would see a lot more flat areas in here, just because you would tend to hit the what am I trying to say? You might tend to hit the zeros, right? If your sampling frequency lined up just right with, there would be a certain frequency that would be invisible, right? Because it would be, I want to say resonant, but that's not the right word. Like, I guess it's something like resonance, where the frequency would line up exactly with the sampling rate, and you would not see anything, which is the same, the same phenomenon you see on TV when you watch old, especially like videos of you watch like videos of a CRT screen, and you actually see the beam going down because the refresh rates are different. The sampling rate is different between the camera and the TV that is being recorded on the camera. Or likewise, you watch an old movie, and the wheels are spinning at a certain rate, but because of the rate of the shutter speed of the camera, it looks like they're moving backwards. And I think you could very easily have a pitch that matched your sample rate, and depending on where in time you started sampling, like phase shift, like what timestamp it was at, it might appear completely blank, even though there was actually sound there. But that's rare, apparently. You would have to have a very pure tone, and so I think that I expected that to be an issue, and that's what's accounting for this striping patterns that you see. But so I guess it would have to be extremely rare. You would have to have something that lined up exactly with some power of 2, I guess, because this is 4 and this is my time scales happen to be powers of 2, so you could just adjust the time scale by 1 to make it not should you ever have that issue. But since I'm not dealing with pure sine waves, I think it's just not even a problem. So this seems to be good enough. And so anyway, the actual algorithm is, well, you take the first byte, you take the second byte, and you have to reverse them. So the second byte is actually the most significant byte. So you shift it over 8 and you add them together. The OR operator, the bitwise OR, works the same as addition when you're talking about So this is 8 bits, and here's 8 bits that are shifted over, so they will never overlap. So you don't have to worry about carries, and so the OR operation is you could also use XOR, but they work the same way. And so that works as addition. So it just saves a CPU cycle, or saves a little bit of time on the CPU, because you don't have to worry about the carry of the bytes of the carry bits. Anyway, so now you would think that so this is a bit mask, right? So this is F is 15, and so that winds up being 1 1 1 1 in binary, the letter one single letter F, and so this is that's 4 ones, 8 ones, and then 16 ones. So this is a bit mask that once you take these two things together. Well, okay, so what's happening is that this number is signed, and so you have a 16-bit number in a 32-bit register, and so you have to add so you have to so the maximum 16. I'm sorry. This is a 16-bit signed number. So it's like a 15-bit number plus an additional sign. Right, so this is the largest 15-bit number. And so when you add that, you're going to get, the carries go through, and you wind up with a leftmost bit that indicates the sign. So this is a 1 byte, 2 bytes shifted over and added together. You have a 16-bit number, that you now want to treat as a signed number. And so you have to add. This is literally 2 to the 16th. I'm sorry. This is not the largest 15-bit number. This is the smallest 16-bit number. So it's 1 0. It's 1 followed by many zeros. So a 1 followed by 15 zeros. And when you add this, this now gives you a signed number, a signed 32-bit number that has the same value as the 15-bit number that you want. And so now when you, but the way signs work is they're 2's complement, and so basically it fills in all of the high bits become 1. This is the can that possibly be right? I'm going into way too much detail here, and clearly I don't have it clear in my head. But we're adding this number, and then we mask it out, and this gives us a signed number. And so then we can now subtract it again. The point is, this looks like a no-op, but because it's done under this mask, so we're doing it. So this is ANDing. What happens is that you wind up getting. Oh, I see. Okay, right. So now let's say this was actually this number. So again, this is a 1 followed by this many zeros. Right. Okay. So the end result of doing this is that you get a number that is between 0 and 65536. So 65535 is the highest possible number. This number actually is 65535, and it's all ones, 16 ones in a row. And when you mask that, so that's the highest possible number you can have, because everything off to the left is 0, and you're ANDing, so all the zeros can't get wiped out. And so then you have a number between 0 and 65535. And you subtract 32768, and you get a number between negative. So if it's 0, you would start with negative 32768, and then if it's 65535, you would subtract this, and you would get 32767. So 2 to the 15th. 2 to the 15th minus 1. Sorry. So it's actually this that adds the sign. This just makes it, yeah. So, so to recap, after all that rambling, you have a byte, you have another byte, you shift the byte over so that they're not overlapping. You OR them together. Now you have a 16-bit sum. You're going to add another 32768, and that is going to cause an overflow for big numbers, which means that you would get a bunch of I'm struggling to put this into words. Like, all right, so you have a 16-bit number. Oh, I see. And yeah, you want to trigger an overflow. So you can't just subtract this number. I'm going to have to draw a diagram. So offline, I'm not going to do this now. I clearly do not understand this well enough to verbalize it. I know it works. It makes sense in my head, but I can't put it into words. Why this is important to do? Because like even while I was looking, I was like, man, this really looks like a no-op. You know, you're adding, you're masking, and then you're subtracting, and then so like what does that do? And so I'll put some binary when I put this on for real. I'll draw the, I'll work through an example. So take that, future Michael. Okay. Anyway, so anyway, the point is that works. That draws it on the screen. So that gives you the actual value. Draw it on the screen. The time scale tells you how to. I'm spending way too much time on this, aren't I? Yeah, there you go. That's the drawing part. Then in the clip scroller, we have this idea of a playhead. So we can easily map so that we set the head time to pixels. We take the position in time. So the head is all of these values. The start, end, and head are all in seconds. And so we map seconds to pixels. So time to pixels, we take t and we multiply it by the mix rate. That gives us how many samples we have, and then we divide by the time scale. Yeah, I'm kind of so the diagram I want here is basically you got 3 lines, and one is the pixel space. The second line is time, so seconds, and so you have a mapping between pixels. Sorry, I'm not pointing at anything on the screen. I'm just drawing in like space here. You got pixels. I should use a real drawing tool. So you got one line here for time, or pixels, right? You got a second line represents time. And then you got a third line that represents data. And the third line is actually huge, right? The third line goes on as many times, because you have 4,000, samples per second. And then you have well, I mean, if you think, it depends on whether you think about which line is longer. Depends on whether you think of it as milliseconds or seconds. But I guess if we have seconds, I was thinking, let's call this one seconds. So then you have a small number of seconds. You have a large number of pixels, but then you have a huge number of samples. And so, and then even then, there's another one which is, bytes, so you've got scaling factors here. So you've got seconds to pixels, pixels to samples, and then samples to bytes. And you've got to project all the way from one to another. And since there's not enough room, well, first of all, there's not enough room to put all, depending if it's a really long line, if you're recording a whole paragraph, there's not enough room to put all of the pixels on the screen, unless you scale it down way low. And so And so you want to introduce like scrolling because you don't want to make it too small to read, right? So that's what the offset is for. And then once I have a scroll bar working, that'll be the intent of that is to to not have to scroll. But you should be able to zoom into the waveform as well and see like the individual pauses between words and whatnot. Anyway, the point is you've got some mapping to do. So now I need to do the thing when so this right here takes time and turns it into pixels. So if this is time right here, I'm sorry, this is time right here. So we can take this time and we can map it to a pixel on the screen. And now we need to go the other direction. If I want to, I have not done that, but I just need to reverse this, right? So, so given the answer, so we say this equals f, it equals r. So we're going to result. So if r is equal to this, oops, come on, that was time to pixels, right? So p is equal to that. So pixel is equal to time times, to time. We want to find t. So given a pixel, we want to find t. So we have some algebra to do here. So we can say pixels divided by this equals t. So that is pixels times this times time scale divided by mix rate is the opposite direction. So func pixels to time ex should be ex turn, right? Yeah, of course, right. That's exactly all it is. All right, so pixels to time should give us that, and so now okay. Is there anything else I want to talk about? This would be setting the playhead, right? So we would do we would do that algebra to get this. So now I need to have a click handler, which ought to be input unhandled input event if event is mouse is you say mouse event input event mouse button. So this is a type check. If input is there a mouse? Yeah, mouse and event pressed print event. Position in local coordinates. That's what we want. Okay. Oops. Let's see if this works. Flip scroller. Event position X. head equals event position X. No, head equals pixels to time event position X. Int. And we're gonna round it to an int. Whoops. Let's see if that works. It might not work at all, but I think it might work. Mouse button. All right. Testing 1 2 3. Testing 1 2 3. So why didn't that work? And that's not what I want. I want breakpoint here. So if it is a mouse button. All right, so it's otherwise it's going to break every time I press tab. Ooh. That must be getting handled then. So input, and try that again. There we go. That triggered. That's going to fail because, yeah. So now if I click out here, it's going to. Right. Yeah, that's working. I think the head is not, either the head does not, I think the timescale or the mix rate is set to 0 when the, no? Let's try this. Testing 1 2 3. Testing 1 2 3. Head 0, pixels to time. Timescale. Let's put event print event. Event? Can I just say event? Input mouse button. Okay, event position. You don't have to. So the pixel is that, and then the time should be that. So what's going wrong? Again, I don't have to wait, save it, and then click. Oh, is head an integer? No? Why is head being set to... Because I set that to an integer. Okay, that's why. I bet. Oh, this is not triggering. You have to do it like that. Oh, that's all it was. Okay. So I guess if you set head without using self.head, then it doesn't. I think this might actually be changed in version 4. I thought I read somewhere that was no longer the case. Okay. So anyway, that was my problem. So it wasn't any of that. But it's nice to have. There's no reason why this shouldn't be a float either. Float, because pixels can be float pixels in here, or can be partial pixels. All right. So anyway, now we can set the head, and that's easy. Yeah. So I guess the trick is you got to make sure you self dot whatever, which triggers this setter. Again, I really thought that was there. So did I move the head? Yeah. Okay. All right. So now that actually gives us the ability to start playback from testing 1 2 3. Testing 1 2 3. Testing 1. This is supposed to start to play from the start of the. Is it jumping back? So if I put the head here. Testing 1 2 3. Testing 1. It's not playing from the head. Playing from. That's weird because it was working before. Testing 1 2 3. Testing 1 2 3. 1 2 3. Testing 1 2 3. Why? Testing 1 2 3. Test 2 3. Testing 1 3. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. No, you don't need that. That's weird because it's weird that it's setting the it's weird that it sets the well, okay, the pixel. Is it setting it? No, it's not. It's not setting it. It's slightly off. It's slightly to the right. Testing 1 2 3. 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 1 2 3. Testing 1 2 3. It's like a couple pixels off to the right, and that's wrong. But the real issue is that it's like the scale is way off. Oh, I'm feeling dumb here. This is a direct linear mapping between Is that what I want? Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. No, not even close. I'm I think that'll account for the yeah, now it's pixel perfect, but testing 1 2 3. Testing 1 2 3. Testing 1 2 3. All right, let's all right, so I need the home button to I need to be able to reset the position. So in the main function, if the scope is home, then we want the clip scroller head to be equal to 0.0. Right? And I press home now. Yeah, it goes back. Okay. Testing. And I'm going to print this now. So when I hit select, this is the space bar. Then I'm going to stop it. Print. Head stopped at. Okay. So now testing. Testing. Oh. Testing. 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 Okay, so that explains that thing. So something is screwed up here in my scaling. Oh, I know what it is. It's because I. It's because I was fooling around with that, and I set the. Oh my gosh. Maybe I set the timescale to 32 somewhere. Yeah, I set this to 32, 128. Oh my gosh, no wonder that was great. Yeah, so that's not working correctly. This setting this probably doesn't do the right things. This probably uses this number, but it doesn't set timescale. Yeah, it doesn't have a set get on it, and so okay. Yeah, this is the horror of mutable state. Okay, so I don't want this. So I'm not going to give it a number at all. Set get set scale, set time scale, and get time scale. And so what this needs to do is set time scale to X. And so this is going to do clip node time scale equals X. And we say func get time scale. It's going to return clip node time scale. Okay, so typeless export. Okay, so this is a I think it's an integer, but it could be a float. So let's actually for the clip, let's just go ahead and do. It's an int here. Let's keep it an int. Clip node object clip. I'll just leave it an int for now. Okay, so okay. Testing 1, 2, 3. Division by 0 in operator timescale. 128. I don't know why that's. I guess you should now set it up here, and then it propagates down to the other one. Okay. Testing 1, 2, 3. Testing 1, 2, 3. There we go. 3. 1, 2, 3. Okay, so that was stupid. Wow. Okay, so all that should have worked, and except for that dumb mistake. Okay, so so really all of that was just to make this happen, which really is exactly what you would expect it to be. Basic algebra would have told you that is what it is, and it would have worked too if you dang kids hadn't gotten involved. All right, would have gotten away with it too. Okay, so yeah, so I guess I had two issues there. One was I was doubting myself about the algebra. That's not true. So three issues. I had to adjust for the start position in our space. So the clip itself is 20 pixels off from the border, and so I needed to adjust for that. And then to make it line up with the pixel perfect and not be 20 pixels off to the right. So now it's pixel perfect. I needed to write this correctly. I didn't need these type annotations, but they're nice to have. I needed self dot here in order to make it trigger the setter. And the other one was I needed to fix the stupid bug where the timescale was off. Okay, so yeah, so that's that's Godot. As you can see, it's got nice little debugger, and you can set, it's nice to work with something that has like an integrated debugger again, especially for this stuff. And it's really nice that you can just save this and it live reloads as you're working. Really nice. I wonder now if I can say now that I have that, can I go back and just out of curiosity, can I go back and go to the flip scroller here and set this to 32? Yeah. Okay. It didn't refresh immediately, but yeah, now you can see that same testing 1, 2, 3. Testing 1, 2, 3. All right, yeah. So there's bugs with that. But yeah. So I'll need to work that out better. Testing 1 2 3. But at least you can. The intent is that as you. Oh, that's interesting. The mouse wheel is is acting as a click, which is not what I want. So yeah, you have to select for which button you're actually pressing. I'm not clicking the mouse wheel. I'm scrolling the mouse wheel, and it's as I move left and right, it's moving the red. It's jumping to. So I'm scrolling up and down now. But if I scroll up and down and move left and right, then it follows wherever I'm scrolling, which is a a simple bug. But anyways, this point is now I can map to and from. I can map from pixel space to time space. I'd say I'm done rambling about this now. So let me. Well, yeah, I don't even. Yeah, I don't even have. I think I'm just going to end the video here, and I'll come back and edit this later. But this is the. This is where I'm at so far. Like I said, right now this is in a fnarbmalix GitHub repository, and that's not the right place for it to be. Eventually, I'll give it a name, and by the time the published version of this goes to my main channel, then the edited version, then there should be a better repository for this. I don't know if it's going to be part of JPrez or just some external tool that talks to JPrez. So today, so next time I present this, hopefully later today or tomorrow, part 2 here will be the talking to JPrez. I definitely want to get like a selection going here. Now that I have this, that was the main piece, but then the next step is to select something and do that. So I might go fill that in and make that this part of this video as well, or whatever. We'll see. But that's the main thing. Then I think this is working well enough to do what I want to do. Anyway, thanks for watching. Sorry, this was rather rambly and unorganized, but yeah.